let's continue with another scenario. In this one, the projectile now is thrown vertically up, but it ends at the level below the original, or it might be starting from this lower level and then end at the upper level. So either way, then this is the kind of projectile that you might be dealing with in an exam. And how to deal with this one? The same approach. Projectile is about the starting point and the initial. Remember, we said in all cases the initial velocity will be guiding our direction to say which direction will be positive. Then we are guided by the initial velocity as it appears in all equations of motion. So initial velocity, if we start by going up, we take upward as positive. And that is the case in this one. Therefore, the final velocity will be heading the negative direction. And one other thing that you should know is that also the delta y here, because from start to finish, we're going downwards in terms of delta y. Therefore, your delta y will also be negative in this case. A, which is gravitational acceleration, in this case, because upward is positive, therefore in our calculation A will become negative 9.8 for calculation purposes. Let's take a similar question whereby this type of motion is also asked, so that now we can know how to deal with this type of question. Now, this is the question. I hope you can see. It's an activity which was drawn from one of the past papers. Activity 3 here now. It was a question just named the activity 3 out of the manual where it was drawn. Learner throws a stone vertically up into the air from the top of a cliff. The stone strikes the ground below after 3 seconds. The velocity time graph below shows the motion of the stone. Ignore the effects of air friction. The moment we ignore effects of air friction, we know that now the stone becomes a projectile. If we look at this one, we can just even tell that by the slope of the velocity time graph, which is negative, therefore, and the slope represents acceleration. If acceleration is negative, therefore negative 9.8 meters per second squared is when now upward is positive. Therefore, that's why we start from positive 10 meters per second and we'll end up at negative 19.4 meters per second. So upward is positive according to this one. So the stone is thrown from a cliff and then passes the level where it was thrown and then now hit the surface below where it was thrown. This is the type of motion. Now let's listen to the questions and see whether we can approach. According to this one, they say the first question: how much time does it take the stone to move from the level of the cliff to the ground as it falls downwards? Calculate the time taken now. According to this one, it's already given in the graph. You can see that now we start from here and then finish here. It takes 3 seconds, also in the statement. Now they say calculate the maximum height reached by the stone above the ground. Calculate the maximum height reached by the stone above the ground. Very good question. In this case, we need to now identify 2 values here. That is the height. If you look at this one, it will be the height from where the stone was thrown to the maximum height, and then also the from here to here, the delta y. So these are the 2 values that you need to calculate in order to calculate the maximum height reached by this one, because they say above the ground, they don't say above the cliff. If it was above the cliff, we'll be only calculating from here to here. So now let's try and make sense of this one and find the 2 heights. The first height will be, if we now just mention what is given, and the VI, a VF, a delta T, and delta Y. So we say upward is positive, Therefore, VI according to this one is 10. VF will be 0 to the maximum height. A is negative 9.8. Since upward is positive, remember A is downwards. We know it takes the time of 1.02 to reach the maximum height. So then now we can calculate the maximum height using any formula with delta y. So the easiest one will be now maybe the last one, no problem, to say delta y equals to VI plus VF divided by 2 all multiplied by delta t. Then the initial velocity is 10, the final is 0 divided by 2 all multiplied by 1.02. That is the time taken. Then we will find the answer to be 14. Is it 14? No, it's not 14, should be 5.1. 5.1 meters. Fine. That is the height. This is the height from, if you look at this question from here to here, that is 5.1 meters. Then now we want to find also the height, where the height of the cliff. Now the height of the cliff, if we use the same information here, but we'll need now the final is no longer 0 for the height of the cliff. The final now will be according to the graph here. If you look at the graph, the final is negative 19.4. Now we have to use the negative 19.4 for the final. Also in this case, you can use any formula with delta y, because we've got so many values now. The time won't be this one, it will be 3 seconds in this case. So if you are using it on a clean slate, we'll have VI, VF, and then A delta t, and then delta y is the one we are calculating. The time is 3 seconds. We still take upward as positive. This is negative 9.8, and then the initial velocity is 10, the final is negative 19.4. Now you see, you can use any formula with delta y, because now you know 4 quantities. Remember, every equation of motion has got 3, so you can still again use the last one, say delta y equals to VI plus VF divided by 2 and multiplied by delta t, which is 10 plus into negative 19.4, then divide by 2. In this case, multiply by 3 in the time take the total time taken. This will give us somewhere around 14.1 meters. This will be the answer. Now this is the height of the cliff, but we need the height from the ground. Therefore we will now say, therefore maximum height reached by the ball from ground now will be the same as 14.1 plus 5.1. This will give us 19.2 meters. So remember, this one, it will be negative. Why is negative? Is because it's above the ground, 14.1 meters down in this case, sorry. So this will be negative. Then negative meaning that anyway we know that the delta y is downwards. So I mean that if the ball is released here, the final point will be here. So therefore the height of the cliff will be starting from the initial to the final. So that's why it's negative, because upward we said is positive according to our choice. Now the next question in this one, they say, consider all these points and then take downward as positive, obviously, or you can take even upward as positive. There will be 2 options. I'll show them both. Sketch the position time graph for the stone while it is in free fall. Take the edge of the cliff as the reference point, then a 0 point indicate the following maximum height and the total time here. Okay, fine. Let's do it in 2 options. If we take upward as positive. If upward is positive, then this will be the graph. If upward is positive, because it starts by going up, therefore we'll start with the positive gradient. This will be the case. Then we'll end up somewhere here. According to our calculation, this will be negative 14.1, and then this will be positive negative 14.1. I think you can see this will be positive 5.1. This will be position in meters, position in brackets meters. Now the time it takes to reach the maximum height, that one is 1.02, and the time it takes to reach the ground is 3 seconds. That is the first option, where we take the height of the cliff as the position 0 and 0, and upward is positive. Now let's say you take downward as positive. The graph will be almost the same, but now we start